In-class activity 19E. 1. When a new technology product, such as a smartphone or tablet, hits the market, initial sales may be very high. Part A. Describe how demand for the product changes over time after the product is released. Well, we could say demand increases quickly once the product is released and may peak within a few months. Then after that, demand would go down, so sales would decrease slowly and taper off. Part B. Now think about the supply of the product and how that changes over time. Do you think the manufacturer always has enough supply to meet the initial interest or demand? What would a graph of supply function look like in this case? Well, the manufacturer may have enough supply for the initial demand, but may not be able to keep up with demand after that. So supply may be higher than demand at first, and then may or may not stay the same level as demand. Over the long run, though, supply should taper off to match the decrease in demand. Objectives for the activity. You will understand how to use polynomial factorization to find the least common multiple of two polynomials. That it may be more advantageous to work with a sum of rational functions written as a single fraction instead of working with an unsimplified sum of fractions. You will be able to add two rational functions by finding the least common denominator. Use graphs and other approaches to explore and verify rational function addition. Let's go to the next page. Number 2. It says, suppose that the supply and demand of a new smartphone is modeled as follows. Demand is modeled by the function d of t, shown here, where demand is measured in thousands of units. The supply is modeled by the function s of t, listed here, where supply is measured, again, in thousands of units. In both cases, t represents the number of weeks since the product launch. Part A, use a graphing calculator to graph both functions on the same set of axes, using the window t between 0 and 50. Describe how supply and demand are changing over this time period. Well, the two curves are listed here, and we can see how supply and demand are changing. We could say demand increases sharply during the first few weeks, and I would just write that here, demand increases sharply over the first few weeks. And it even seems to, we could say, peak around week 4. Then it starts to decrease slowly. And finally, it seems to be there's a horizontal asymptote at y equals 0. So it's going to be going to 0 in the long run. So let's see. Peaking around week 4, then slowly decreases to 0. And then that would be for demand. Now supply, the supply function, it's initially above the demand function. Then it at some point it crosses the demand function as it decreases. And function as it decreases. Part B. Let C of t equal d of t minus s of t. In this context, C represents the excess demand above the supply. Find the function C of t and write it as a single fraction. Show your work. So we could look at the denominators. So for the first denominator, d of t, if we think about it, I'm not going to write it like that. Let me write it like this. I'll just put the denominator here. So if we look up at d of t at the top of the screen, the denominator is t squared plus 10t plus 25. And if we factor it, we're going to get a t plus 5. Actually, we'll get it twice, t plus 5. Look at s of t. The denominator is t squared plus 9t plus 20. That factors as t plus 5, and then a t plus 4. So if we look at the denominator that we need to use to add these rational functions, it's actually going to be a t plus 5, a t plus 5, and a t plus 4. Let's go to the next page. For part C, did we answer part B? Let me just quickly read this. Find the function c of t and write it as a single fraction. So we did not answer that completely. So let's write c of t here. And the first fraction is 150t 150t plus 90 over the t squared plus 10t plus 25. Then our second fraction, which was 50t plus 150 over that denominator, the second denominator, which is t squared plus 9t plus 20. So it looks like, let's see what we're going to need. We're going to need 150. I'm going to write this underneath. Whoops, might not have enough room there. I'm going to write it here, equals. And then the numerator is going to start out being 150t plus 90. And this has a t plus 5 squared. It's missing the t plus 4 piece. So it's going to need the t plus 4. And then plus the 50t plus 150. This has a t plus 5 and a t plus 4, but it's missing one of the t plus 5s. So it's going to need a t plus 5. All of this is over t plus 5. Instead of writing that twice, I'm just going to write it as a square, and then t plus 4. So if we simplify this, we're going to end up eventually at 100t squared plus 290t minus 390. And that is over the same denominator, which is t plus 5, that quantity squared, times t plus 4. Now we can go to part C. Part C says find the time t such that c of t is equal to 0. Interpret this in terms of demand and supply. So what we'd have to do is solve the equation 100t squared plus 290t minus 390 over t plus 5 squared, t plus 4, and all that is equal to 0. So we have a fraction equal to 0, so that means the numerator we want to set equal to 0. So it's going to be 100t squared plus 290t minus 390 equals 0. We could even divide out a 10 from each of these terms, make it a little bit smaller. We have a 10t squared plus 29t minus 39. Whoops, I did not mean to do that. Here we go, minus 39 is equal to 0. And this is factorable. If we factored it, we get 10t plus 39 times t minus 1 is equal to 0. So we're going to see that in 1 week, the supply and demand are equal. So in 1 week, supply and I'm going to put this, demand are equal. All right. Part D, let me just scroll up a bit here. There we go. Part D, explain why it's easier to work with the equation in part C as opposed to solving the two fractions there. Well, the equation in part C involved only one fraction, so it's fairly straightforward to set the fraction equal to 0 and solve the equation. The more complicated expression is more complicated to solve, and it just takes some work to cross multiply and so forth. So now let's move to part E. Explain why it's easier to graph the function you found in part B, well, compared to the function in the form listed in part E. So the form of the function in part B is fairly easy to enter into a graphing calculator or the app, and it's only one fraction. So the more complicated form, it's more difficult to enter. Let's go on to part 3. Just scroll up to the top here. So part 3 says, in an Ironman triathlon, athletes compete in three different activities. They swim for 2.4 miles, cycle for 112 miles, and run for 26.2 miles. The events are completed in that order with no break. Part A triathlon participant estimates that she cycles 5 times as fast as she swims and that she runs 3 times as fast as she swims. Find the function that gives her total time to complete the course in terms of her swimming speed. So the function is, this is part A, so let me write R of X is equal to 2.4 over X plus 112 over 5X plus 26.2. That's a 3 over 3X. Part B, one rule for an Ironman triathlon is that there is a strict 17-hour time limit to complete the race. How would you use the information from part A to find the speed needed to complete the race in this time frame? Well, we would use the same equation. We would just set it equal to 17. So we could just say, this is actually part B. Let me just go down here. We'd write 17 is equal to, and we'd write to 2.4 over X plus 112 over 5X plus 26.2 over 3X. So that would give the minimum swimming speed and also the cycling and running speeds needed to complete the race in 17 hours. Of course, to complete the race in less than 17 hours, the competitor would have to swim, cycle, and run at faster speeds as well. Let's go to part C. It says simplify your answer from part A to write it as a single fraction. So we could write R of X is equal to, we have 2.4. Now, if we look at the denominator, the common denominator is going to be 15x. I'm just going to write that over to the side here. The 2.4 already has the x part. It's missing the 15. And then 112, it has a 5x. It's missing the 3 to make 15. And then 26.2 has a 3x. It needs a 5. And this, I'll put over 15x. And if we multiply all this out, we would get 503 over 15x. Part D, use your answer from part C to determine what this competitor's swimming speed should be in order to complete the race in 17 hours. What if she wants to complete the race in less than 17 hours? So let me just move this up a bit. And what we could do is, let's see. All right, so we could write, let's see, R of X would be R of 17 is equal to 503 over 15 times 17. And that would be 503 times, that's going to be 255. And 503 over 255, this is approximately 1.97, and that would be in miles per hour. So she would need a speed about 2 miles per hour for swimming and 10 miles per hour for cycling and 6 miles per hour for running. And she'll complete the race in just under 17 hours. Part E, explain why the equation in part D is easier to solve than the equation in part B. Well, the equation in part D involves only one rational expression. It's fairly straightforward to cross multiply and solve for X. Let's go to part 4. And part 4 says, list 2 ways to check your answer after you have added 2 rational functions. Okay. One way would be to evaluate the original functions at certain inputs, say 0 or 1, and then add the results. Then compare that to the output that results when you evaluate the sum at those points. Now, this is a good quick check, but it's not foolproof. It's possible that you can make a mistake and that evaluating these inputs won't pick up the mistake. Another way is to graph the sum before finding the common denominator and simplifying, and then the simplified sum. If the graphs match, you can feel pretty confident that you did the algebra correctly. Again, not foolproof, but it's something. And let's see, these 2 approaches are good. If the answers don't match, then you know you've made a mistake. Another approach is to set the 2 functions equal to each other and cross multiply. This involves a lot of algebraic simplification, but if you do it correctly, then it should work. And finally, another approach would be to work with another person, solve the problems independently, and compare your answers. All right, that's the end of this video.